Here is the content, which includes background information, problem statement, objective data set, data description and processing, model selection, dataset division, splitting and fitting model, confusion matrix, that's ANN, model accuracy comparison, results and conclusions. So here is background information. Advancement in AI and data science with machine learning, there is an opportunity to automate and optimize the process. In each field, AI is bringing up modern solutions and giving an easiness to everything. AI-based classification and testing techniques provide scalable, accurate, and most effective methods. Also, it provides time-saving things, time-saving solutions, and money-saving solutions. So AI is really an amazing in every field, and it's modernizing and revolutionizing the fields in which it's working. So here is my problem statement. The quality of wine and human testing to check wine quality in most precise and trusty way, enhancing accuracy of wine quality check with AI models. Actually, the quality of wine and human testing are interrelated with each other. The testing by human is not so accurate, and somehow it goes personal, or it goes in a consent. So, to check the wine quality in most precise and trusty way, AI is necessary. The machine learning model gives us accurate and precise methods to check the quality of wine. So rather than human testing, AI is more precise and more quick and more easy. So objective of our assessment is, our goal is to use machine learning models like ANN, SVM and RFC to predict wine quality. This can optimize wine production, improve customer satisfaction and increase sales. Actually, in industry, different models are needed to optimize wine production and to improve its quality and to increase customer satisfaction. Although man testing is there and many other methods are there that are cultural or maybe local, but with machine learning it can be improved in a ways that it will be much better and will result in and results in a satisfaction and increased sales to the companies, to the industry, and there will be many more benefits to human health also. When the one quality of wine will be the best, then the health issues will not be many as now in a days. So this is objective of our assessment. If we move to the dataset, the dataset is used for this project was sourced from Kaggle and is titled as red wine quality. This dataset is also available from UCI machine learning. So here is its link or its repository where we have downloaded the dataset. Data description and pre-processing. The dataset features includes fixed acidity, volatile acidity, citric acid, and residual sugar. Additional features are chlorides free and total sulfur dioxide density, pH, sulfates, and alcohol. The target variable is quality and integer between 3 and 8. We have set our values from 3 to 8 where we are checking the quality of the wine. In some of our models we have set it from 0 to 10 also. Pre-processing is very necessary in data handling to handle missing values and outlier detection. Pre-processing is very necessary. In somehow we also have to fit some values where we have missed the values or where we have empty values. So our pre-processing involves handling missing values and outlier detection. Future scaling using standard scaler, I mean max scaler is essential, so we have used 10 scaler, and scaling is important before applying ANN, SVM and RFC model. And because this ensures that features contributes equally to the model's learning process. If we don't do this, then the data will not run in appropriate way and the models will not makes its way to the accuracy and they will take much time in processing and to learn the model. So we have to handle missing values and outlier detection, so that our models works efficiently and with accuracy. Model selection is an important factor in data set when we have to train some model, or when we have to make a model and then we have to train it for some data set. Artificial neural network ANN is a powerful for complex patterns, although it can handle any function and can learn to approximate any function, making them powerful for complex problems. But computationally it's very expensive to train, especially for large data sets. If we goes on sport vector machines are effective in high dimensional spaces and robust against outliers. For example, SVM with RBF kernel C1.0, gamma 0.1, and achieve high accuracy. So also this have pros and cons. SVM are robust to noisy data and can handle high dimensional data, but SVM can also be computationally expensive to train, especially on large data set, and moreover it becomes impractical for very large data sets, because they are very tough to handle large data set values, and they take much time in training, so they are expensive in that sense. Random forest classifier, that is RFC, combines multiple decision trees to improve accuracy and reduce overfitting. For example, RFC with 100 trees, max DEP and min samples leaf 5 performs well, although it can handle high dimensional and are robust to noise, but somehow it's generally fast to train even for large data sets, but in overfitting they can suffer overfitting, and especially when the number of trees is too high. So these are not suitable for complex problems, but for simple problems, and they are more accurate and trained in low time as compared to support vector machine and artificial neural network. So random forest classifier are much better for the data set that have low variables or minimum variables. Data set division is another important factor in machine learning, where we splits the data into train and testing data. Splitting the data set into training and testing is crucial. Evaluation metrics for classification, accuracy, precision, recall, F1 score, confusion matters. So justification for selecting appropriate metrics is essential. So we split data in forms of 80-20 ratio or 70-30 ratio, that is suitable for the machine learning, where we split the test data into train and test. And training data is used to train the AI model, and the testing data is used to test whether our trained model is good or working worse in different models. So it's a crucial point where we divide the data. Here is our code where we are splitting and fitting the model. In the first steps, we are setting our target variables, and then we are converting quality into classification problems, so that we may have proper numbers where we can classify them: a low, 0, medium, 1, and high, 2. And then we are splitting the data into train and test, that is 80-20 ratio, and then we are printing its shapes. After printing, we are fitting the model with stand scaler. Using the stand scaler, that model is fitted so that it can be trained easily on different models and produce high accuracy with different models. Here is our confusion matrix where we have high, medium predicted and low predicted data. Here is that's a confusion matrix of ANN. So that's our model accuracy comparison where we are comparing different models that we have trained and then tested. And there is ANN random forest and SVM sport vector machine model. Random forest model is giving us a high accuracy because the data set is small and the variables are easily available to train. But for ANN and SVM, they makes the problem complex and takes much time. So they are giving us low accuracy as compared to random forest. Here are our results showing that ANN accuracy is 60%, random forest accuracy is 71.25%, SVM accuracy is 59.69%. So the best model is the random forest with 71.25% accuracy. Model performance analysis identifies the most important features for predicting wine quality. Model prediction can be used to improve wine production and quality control. And this data shows that the random forest accuracy is much better because the data set was having low values or minimum values that can be trained easily, and random forest model handling it in a much better way than ANN and SVM. In conclusion, if we say our goal was achieved goal of predicting wine quality, we have achieved. It will be easier to test and to predict the quality of wine using AI models. It can be ANN, SVM, or random forest classifier. So it will be much easier than human beings and human testers, cause human testing may be results into low quality, or maybe results into concern with personal things. So AI is much better than in this way. RFC performed best identifying the key features because it performs well on low or various data set. So RFC has higher value of accuracy. Other algorithm we can for further our future work we can explore other algorithms like ANN, SVM, and other different AI models. And by collecting further data, we can do further work on this model to make them more accurate and more precise to identify the quality of wine rather than human beings or any other testers that are used locally or at cultural based or in primitive base.